In 1989, a major earthquake strikes Northern California. While the quake lasts only 15 seconds, 67 people are killed and damage is widespread. Each year, thousands of earthquakes occur throughout the world. While most are minor, a few cause great damage and loss of life. What causes the earth to rumble and shake? Why do some areas of the world experience earthquakes and others do not? Will scientists ever be able to forecast earthquakes? We're all familiar with a globe. It shows what our planet looks like from the outside. It shows the great land masses called continents and the bodies of water called oceans.
It's like just a little island all by itself.
It looks like Greenland.
As useful as globes are, they are unable to show you one very important part of our planet, the inside. The Earth's interior consists of several different layers. The inner core, which is believed to be solid iron and which is very hot. The outer core, which is believed to consist of rocky material so hot and under such great pressure that it is in a liquid state. The mantle, which is not so hot as the outer core and not so liquid. The mantle's outermost portion is solid. This is the solid outer portion of the mantle. Above this, the outermost layer of the Earth, the crust. Together, the crust and the solid outer portion of the mantle form the Earth's outer shell. They are referred to as the lithosphere. It's not always easy to see the Earth's crust. It is covered by vegetation and oceans. But if you could drain the Earth's oceans and strip away our planet's vegetation, the Earth might look something like this. Now we can see the Earth's hard outer shell. And if you look closely, you can also see where the shell is cracked. The red glowing lines mark the places where the Earth's shell is cracked into small and large pieces called tectonic plates. Each plate carries a continent, or an ocean basin, or sometimes both. The plates are moving 1 to 2 inches a year in different directions, carrying continents and ocean basins with them. Millions of years ago, the Earth looked something like this, every continent in a different position. They were so close together, they formed a single supercontinent called Pangaea. But even then, the continents were moving a few inches a year and kept moving until they reached their present-day positions. The theory that continents move is called continental drift. When you look at a globe today, you are looking at only a moment in time because the continents are still moving, inches a year, too slow to see as they move farther and farther apart. Then the continents will stop moving apart. They will change directions, coming together once again. Millions of years from now, scientists expect the world to look entirely different. Every continent in a new position, carried there by the moving plates. While we can't see this movement occurring, we can see the effects. Earthquakes are just one of several dramatic effects of plate movement. Here's why the plates are moving. Scientists believe material in the mantle is circulating, much as it is doing here. The movement may be caused by heat within the mantle. You can get an idea of how heat can cause a circulating movement by watching rice as it boils. What you see happening within this beaker is similar to what's happening within the Earth's mantle. As mantle material moves, perhaps only inches a year, it causes the plates above it to move as well. In some places, plates are moving in opposite directions. They are moving apart. The area where two plates are moving apart is called a divergent boundary. Most divergent boundaries are located below oceans. This is a cross-section of a divergent boundary located below the Atlantic Ocean. Scientists have discovered that as the plates move apart, hot liquid rock called magma rises from the Earth's mantle. The magma rises because it is lighter than the surrounding material. Magma is the name we give lava before it erupts from volcanoes, as it is doing here. And just as this lava is doing, magma hardens into rock when it cools. As the magma rises and cools, it adds new crust to old, spreading the ocean floor. This area of rising magma is known as a mid-ocean ridge. This shows where magma is surfacing between plate boundaries, creating a mid-ocean ridge that circles the Earth. The ocean floor spreads in one direction on one side of the ridge and in the opposite direction on the other. The mid-ocean ridge is where plate material is created. This is where plate material is destroyed, an area where two plates are colliding, a convergent boundary. This is a cross-section of a convergent boundary. In this example, the plate on the right is carrying an ocean basin and is moving in this direction. The plate on the left is carrying a continent and is moving in the opposite direction. The plate carrying the ocean basin is heavier and is diving beneath the plate carrying the continent. The leading edge of the diving plate is consumed back into the Earth's mantle. When one plate dives beneath another, it is called subduction, and the area where it occurs is called a subduction zone. Subduction may resemble what is happening on this lava lake, as sections of hardened crust dive beneath other sections. The highlighted areas on this globe mark convergent boundaries. Subduction is occurring at most of them. These are the areas where plate material is destroyed. Here again are divergent boundaries, where plate material is being created. Again, most of them are beneath the oceans, creating a mid-ocean ridge that circles the planet. The grinding of plates has been going on for so long that most of the Earth's crust is filled with cracks, not unlike the way this rock is filled with cracks. Scientists refer to a crack in the Earth's crust as a fault, and it is in these faults that earthquakes originate. One side of the fault tries to move in one direction. The other side of the fault tries to move in a different direction, but the two sides are locked in place. They can't move until enough stress builds up to move them. If you were to bend a stick slowly, you would find that it won't break until sufficient stress builds up.
Oh my gosh. Oh, wow. Look at that.
That's what happens deep underground. The fault will remain locked until enough stress builds up, and then it will suddenly release. One side of the fault sliding past the other with a tremendous burst of energy. The energy that is released is in the form of seismic waves which radiate or move outward. If the disturbance is big enough, the waves will eventually reach the surface, where they can cause considerable movement referred to as an earthquake. The place where a fault slips is called the earthquake's focus. The point on the Earth's surface directly above the focus is called the earthquake's epicenter. What's interesting about earthquakes is how most of them coincide with plate boundaries. These dots mark the locations of recent worldwide earthquakes. These lines mark plate boundaries. You can easily see how most earthquakes occur along plate boundaries. They occur near divergent boundaries, convergent boundaries, and they occur near the third type of boundary, a transform boundary. This is where two plates slide past each other. The world's most famous transform boundary is located in California. It splits the state into two sections. Here, the plate on the left is being driven in this direction. The plate on the right is being driven in the opposite direction. The two plates will remain locked until sufficient tension builds up between them, and then they will release in a sudden jerk, causing an earthquake. The amount of movement might only be a few inches, but could be several feet. The giant fault that is created by this plate movement is called the San Andreas Fault. In some places, the fault is clearly visible on the Earth's surface, appearing as a nasty scar in the landscape. The San Andreas is over 500 miles long and slices its way past several major cities. It is among the most active faults in the world and one of the most dangerous. Scientists predict that a major earthquake will strike here in the near future. That's why they want to learn as much as they can about earthquakes. This man isn't going for a hike. He's in the mountains to install earthquake monitoring equipment. This device is called a seismometer. It detects movement in the ground and sends out electronic tones. The tones may not sound like much to you or me, but they do to computers, which can decipher the tones into meaningful information. Hundreds of seismometers have been buried as part of an earthquake monitoring network. The seismometers are connected to a central computer miles away. Here, the tones are analyzed and provide scientists with important information about surface movement in their area. The symbols on this computer monitor represent the locations of buried seismometers. The thin lines represent faults. When an earthquake occurs, scientists are able to pinpoint its exact location. Computers also help scientists analyze the different types of seismic waves that occur during an earthquake. The first waves that reach the surface are called P waves. P waves compress and stretch the material they travel through, shown here in this model. This can be more easily seen using a model with a grid pattern. Here you can see that some sections of the grid have been stretched and other sections have been squeezed together. The next waves that reach the surface are called S waves. S waves produce an up and down rolling motion in the Earth's surface. There are other types of waves as well, and a single large earthquake can produce all of them. By examining various wave patterns, scientists can determine the strength of an earthquake, which is referred to as its magnitude. Earthquakes are assigned a number according to magnitude. The numbering system is referred to as the Richter scale. The larger the number, the greater the earthquake's magnitude. The Loma Prieta earthquake of 1989 registered 7.1 on the Richter scale. Even though the epicenter was 60 miles away, damage in San Francisco and Oakland was considerable. Had the epicenter been closer, the damage to these cities could have been much worse, and thousands of people might have been killed. The closer large populations are to an earthquake's epicenter, the greater likelihood there will be for death and destruction. A quake not much larger than the Loma Prieta quake struck China in 1976. The epicenter, though, was near a highly populated area, and as many as 650,000 people were killed. The most devastating earthquake to strike the United States was the San Francisco earthquake of 1906. Nearly 700 people were killed, and the city center was destroyed. Scientists believe another devastating earthquake could strike a major city like San Francisco or Los Angeles in the very near future. A quake so large, it would have the potential of killing thousands. That's why some cities conduct readiness alerts that simulate the kind of devastation that could occur, with the hope of being better prepared. That's why scientists study the damage caused by earthquakes. In this way, they learn more about the destructive capabilities of earthquakes and what can be done to avoid such destruction in the future. Scientists hope that one day they will be able to forecast earthquakes in much the same way they can forecast weather. So far, earthquake forecasting is not very precise, and people living in earthquake-prone areas are advised to expect an earthquake at any time. The next major earthquake might not strike for years, or it might strike within seconds. In this program, we have seen how most earthquakes are triggered by movements in the giant plates that form a shell around the Earth, and that most earthquakes occur directly above the edges of these moving plates. Earthquakes can occur near divergent boundaries, convergent boundaries, and transform boundaries. We've seen that earthquakes occur when one side of a fault suddenly slides past another. The energy that is released is in the form of seismic waves, which radiate in all directions. When these waves reach the surface, they can cause considerable surface movement and destruction. The place where a fault slips is called the earthquake's focus, and the Earth's surface directly above the focus is called the epicenter. We've seen that the first wave to reach the surface is called a P wave, and the second wave is called an S wave. We've seen that scientists use instruments like seismometers to record and measure these waves, helping them determine when and where an earthquake occurred and how powerful it was. The strength of an earthquake is referred to as its magnitude. Earthquake magnitudes are measured according to the Richter scale. We've seen the results of devastating earthquakes around the world and learned that an earthquake's destructive capability is greater near the epicenter. While earthquakes are frightening, they serve to remind us that our planet is in a constant state of change. While we may someday be able to forecast the occurrence of earthquakes, we will never be able to alter the great forces that are at work within our planet.